here is the problem du jour.
What is that?
Problem of the day.
Yeah. Oh, okay. So like meal dish.
Okay, read through this, please. Draw a picture. I'd like you to draw a picture. We did this in physics today.
How did you just
We actually did do something really similar.
No, right. You wouldn't have to. Right. We're asking a little harder question.
Do we have to take in the kinetic equations?
I gave you the one you need.
So you should show us how to do the physics problems.
No, because my hair
I don't steal all away.
All Cooper's thunder.
Well, we won't learn how to do them really easily until next year in calculus, or next year in applied physics, or applied calculus physics.
calculus with applied physics.
Yeah.
Or physics with
Yeah, that's
calculus
right.
applied. That's what my uncle told me to take.
Yeah.
He's an idiot. I'm just kidding, he's kind of smart.
So, okay, so draw a picture. Draw a picture.
Okay.
Do you have any Advil? I don't.
We should not ask the teacher for drugs.
Teachers can't give students drugs. No, I probably can't, but if I had some, I don't have any anymore.
Probably
But
can't give us drugs.
You got any?
Just not legally. If you ask
Wait,
for
Most people just leave it alone.
They can, you know where else they do? Well, the office used to do that stuff, but I don't think they do.
I think they do actually.
Do they?
What? The one that sits in the back.
Becky.
Yeah, Becky.
You gotta know who to do it.
Yeah, man.
abolish drugs.
You gotta know who has the right drugs.
So get the picture drawn here. Come on. Okay, that's looking good.
I'm kidding.
Didn't we?
And you guys have the page over me.
Yeah, it's not fair.
It is so hard to do questions.
We're actually smarter than half the people in our business.
We have to factor in the angle of the sun.
No.
What does it mean 12 meters away from the top of us?
Well, that's what you have to interpret. You got to be able to draw this picture.
Did they walk out in the air and drop it?
exactly. How are
That's what I
Oh, yeah.
How did they get?
Did they walk out in the air and drop it?
Oh, jetpack.
Oh, okay,
So
the
it's-
Jetman.
How'd they get on top of
So it's 12 meters horizontally.
What kind of man gets stretched
Yeah.
on top
So
of
wait, you're saying they walked across the air and dropped it 12 meters away?
Wait a second.
Is that like,
Or
on a
like,
jetpack?
it's, okay,
Okay.
so it's like,
What kind of
It was.
Wait, we have to draw like that.
We're going to ignore air resistance to this.
here's where it was dropped. So I gotta draw it.
It's been coated with slippery and friction.
That is
That's a long joke. That's good.
We are on Earth.
How fast?
What's that?
We're on Earth, I'm assuming.
We're on Earth.
Okay.
How fast and in what general?
So the acceleration of gravity is 9.81.
Right. Well, I accounted for once again
It's accounted for in that?
in the equation, yeah.
Okay.
How?
What is that the equation? What?
V
times.
It's a time a. Oh, hang on. I forgot a square. Whoops, hang on.
Yeah, it's time squared away.
Wow.
Where's Ethan?
AT squared plus V naught T plus S naught, or Y naught in this case. So we need a squared there. My bad.
It's fine.
Yeah.
Rookie mistake.
You haven't gotten that far anyway yet.
You'd be surprised.
I just want to see the picture. I want to see a good picture.
Okay, well, I have a picture.
Who's got pictures to show
Here's my
me?
picture.
I'll draw
Okay,
you.
that's pretty good. Pretty good. Pretty good. Pretty good. But what I'm missing, I'm not seeing any triangles in these pictures.
Well,
Yeah,
like-
you said draw the picture of what happened. You want to just draw a triangle?
I want triangles. I want
I have a
triangles.
triangle.
And how far does the lamp protrude from the top of the post if it goes over like that? It's like, it's not gonna be just at the top. It's not gonna be facing down if it's just at the top, because that'd be on the post.
Yeah, and the top of it isn't perfectly flat. It's curved.
Okay, well, here's your triangle.
Well, that's the wrong
There
triangle.
you go. Here's your triangle.
Let's talk about the picture first of all,
Why is this ball being dropped in the first place?
Yeah, what are we trying to
so we can do this problem. That's why it's being dropped.
Why would they find
practicality in this class.
Reasonably
Yeah.
12 meters.
I like Ish's
Jason proved that we are never used.
Well, I put a plank out there, and walked it. I was mindful too.
You seriously, you never seen any flat balls draw. Use one hand.
Draw yin yin.
I walked on it.
Okay, so let's.
So good for have to wear flip-flops.
Just us.
Oh, I know what they did.
Alright.
Okay, I get it.
Okay, here's my picture.
And why is the lamppost only 12 feet tall? Most lampposts that I
12
see
meters.
are
No, no,
Oh,
20
okay,
meters.
meter.
That's way too
20 meters. That's a major league lamp. That's up there a long ways.
That's a highway
60
lamppost right there.
It is.
What's your wall?
So are you dropping onto the freeway?
Okay, that's the picture that I have exactly. If you're about
That's-
to drop all right.
Almost.
Oh, so that's the line.
Oh, okay. I guess you're pretty good.
Okay, but see, my lamppost does this, Mr. Roya. And here's the lamp.
So yeah, what is it?
Then it's got to be okay, but it's got to be 12 meters from the lamp.
Okay.
So the lamp is here,
Yeah.
or the lamp like 12 meters.
We don't care about the support at all. We just care where the lamp is, where the source of light is.
That's a song.
Okay?
Okay. I totally know what you're saying now. Oh
Okay.
my goodness. I'm gonna make a very elaborate drawing of this.
I don't ever pass
Is the ball gonna be spherical?
Hey, you have to have the ocean background.
No, is
It's at sea level. If it wasn't at sea level, we'd expect it.
it. You should challenge it.
is it falling through the air?
Let's see.
Did you say a drawing?
Okay.
Okay. Little. Not giving you another universe qualification.
It's okay. Picture is.
Oh.
Oh.
Wow, that ball is very big relative to the light.
What's this doing?
Drawing big balls.
Mr. Roya, I have a really good drawing. Okay, Mr. Roya.
You like my picture? You see what I'm doing with my picture?
Can I draw the next picture?
Hey, come check my picture out.
Is it good?
Can I
Oh,
draw?
yeah.
Can I draw the next picture?
I want to draw. Here, I'll show you up here.
Put it on his elbow.
Wait, there's a triangle and everything.
Oh my goodness.
Yeah. Is that right?
They're on track with that.
Yeah,
That's
wait,
on track.
that doesn't make any sense. No, you can't.
Okay, let's write some numbers in.
Let's drop from 12 meters.
No, 12 meters away. So, okay, take a look, please. Take a look. Here, now we're getting busy.
The distance from red to
So
yellow is
that
12.
distance is 12 meters
I've already got that. Down.
from 20. Right. So this distance.
Okay, so it's already mid-fall.
Oh,
Right. So that's in mid-fall. It's already fallen a ways.
Oh, so the angle trajectory of the light is.
Right.
What?
Okay, everybody with me?
Yeah.
Okay, take a look.
Just continue.
Take a look.
Okay, I've changed mine now, Mr. Roy.
Okay, we good? Okay, so there's our stuff,
I
right?
know, but I made this angle with the light, so it would be that with the bulb.
Now let's plug in some variables here. What are the things that are changing? The angle? Okay. Okay, so the angle's changing,
Yeah.
right? So let's call the angle we could call theta. Right? So let's draw that in. There's
And the distance away from the ground.
and the distance away from the ground. This distance right here we could call y, right? The height of the ball. Yeah. Everything else is constant. Agreed?
Yes.
So let's write down then what are the things, let's take our snapshot variables. At this snapshot in time that we're talking about right here, what are we given? Directly or indirectly? What do we know?
Oh, gravity.
Okay, well, we know,
Well, we know it.
really the only thing that we're given directly is the 1 second, right? Okay, Well, I mean, that's what we're told. The shadow. We want to know how fast is the shadow moving 1 second after the ball is dropped. So we're given the fact that it's after 1 second. Now, the fact that we know that it's 1 second allows us to calculate a y, though, doesn't it? Right? So we're told here that t equals 1, which allows us to calculate that y of 1 is just 15.1. Right? If I plug 1 in for t, I get 20 minus 4.9 times 1 squared. So 20 minus 4.9. So 15.1 is our height. Okay? We don't know, actually, we may not even need theta. We don't need theta really, do we? They don't ask about theta anyplace. I mean, we might. We'll leave it in there, but we may or may not need it. Now, what they're really asking about is how fast is the shadow, and here's the shadow on the ground right down here, right? That's where the light is obscured by the ball. So if we just trace, that's where the shadow is going to sit. What's going to happen to that shadow as the ball drops?
It's going to disappear for a second and come back.
Well, but isn't it going to? It's going to as the ball drops. Doesn't that push the shadow closer to?
Yes.
Yeah.
Right. Okay.
Is that a spotlight?
Isn't it going to be negative up?
Okay.
Oh, the shadow.
Okay. So here's our shadow on the ground right here. Right. Now we need another variable here. We have to know what's the rate at which the shadow's moving. So we have to have a variable that represents the position of the shadow. What would that look like, maybe? Call it x, sure. And what would x measure?
Meters.
From where to where? Okay, so suggestion is from here to here? Yeah, that's fine. What else could it be, by the way?
Just from the horizontal.
Okay, it could be from the lamppost to here. Now, this is going to sound weird to you, but both of those would work. They would work equally well. And the reason they would work is because they're both going to measure, they're both going to change at the same rate, aren't they? Whether I call x this distance or this distance, this distance, it doesn't matter. It's going to be changing at the same rate. We could measure from where the ball is going to land, right, from there to there. So from there, I better do this since on camera, from there to there would be one possibility for x, or from there to there. Being as 12 is constant. Doesn't matter. So let's just say it's from here. Let's call this distance right here x. And we want to know then what is x dot. What's the rate at which x is changing, right? So can we come up with some kind of equation there? That's what we need. That's the hard part always, is the parent equation. If we ignore the dots here, can we come up with an equation that relates x and y?
Yes.
We can. How are we going to do that?
Y equals.
Y
Y
equals.
equals.
Well, okay, their suggestion is, can we use that theta? But if we use the theta, we've got to introduce another variable there. Can we do it without introducing that theta?
Yeah.
Oh, no. I'm being honest now. You want to do it? Sorry.
Wait, did you know?
But that's going to bring in a lot of money.
Probably not.
Create a logarithm.
Okay, so what do we got now? Can you think of? We got to come up with some relationship? I'll give you a hint. It's a geometric thing we're dealing with,
Pythagorean
not
theorem.
trig. And it's okay. Pythagorean theorem makes sense as something people would offer as a possibility.
But it's not random.
It's not. The problem with the Pythagorean theorem is, the problem with the Pythagorean theorem is it would require us to know the hypotenuse, and we don't.
You don't know that at all.
No. Now, we got to take advantage of the stuff we do know, though, right?
We know that it's x squared plus y squared.
Square root of x.
Well, true, if we use Pythagorean theorem. But here's some stuff we do know. We know that distance is 20. It's fixed. We know that distance is 12. So, those must be things that we got to take into consideration.
Yeah.
So can we come up with something here? Some kind of geometric relationship?
They proportion.
What?
I did something there.
You did?
Oh.
Okay, proportionality is important here. Can we come up with a proportion? That you're onto something. That's it. But just keep going with that. Can we come up with two things that are proportional that would allow us to set up an equation?
Input?
Oh, is it 12 plus x?
Okay, we got similar triangles, right? We've got these are. Wouldn't you agree? These are two right triangles that share an angle, right? These two sides are parallel, so those are similar triangles, aren't they? Right, the little guy and the big guy. So there's many ways we could couch this. We could write the equation in different ways, but what's a way that we could set up a ratio equation based on those similar triangles? I was hearing it. We could say, for example, I'll get you started. For example, y over x would have to equal what?
20 over
x plus 12.
Right?
Good job.
The ratio of the height to the width of these right triangles has to be equal because they're similar, right? So y to x is 20 to x plus 12. Make sense? Okay, now does that have everything we need? Sure it does. It's got y's and x's in it. That's all we need. Right? So now we could differentiate this right now if we want to, or we could cross multiply and do some of that stuff. What do you recommend? How come? That's good.
Because it made it sound like it was easy.
Okay.
Quotient rule.
Okay, because we don't want to do quotient rule over here, do we?
No.
Right? We'd rather lump everything together. So if we cross multiply, let's do the math here. If I cross multiply, I'm going to get xy plus 12y equals 20x.
Yeah. That's good stuff.
Product rule is easier than quotient rule always. So now we can differentiate, right? Can we plug the stuff in first, the values?
No.
No, can't. Because we have to show that the things that are variable, that are changing, have to appear as variables in here. The stuff that's not changing, the 12s and the 20s, that can look like numbers. It should. Because then the calculus gods will treat those as constants, as they should. Right? So now if we differentiate this, so we got a good parent equation, there's step 3, now comes the calculus step. Step 3. What's this first term going to look like when we differentiate?
X6 dot.
X.
Why not? Are we differentiating in terms of
T.
oh, x
Right.
dot, y dot?
No.
Or x dot, y dot?
X times
No, it'd just be x, y dot.
X, y dot. First times derivative of the
Oh.
second plus second times,
X dot.
okay, plus
Y dot?
12 y dot equals,
20 x dot.
okay, and we're trying to find x dot, right? Agreed?
X dot.
Okay, so then we want to solve this for x dot. So let's get all the x dot terms maybe on, that side. Doesn't matter, either side. Right side. Thing is, we'll already have the other stuff over there. So if we do that, if we get the x dot terms on the right side, we're going to get xy dot plus 12y dot equals 20 minus y x dot. If I get this term over here and then factor out an x dot,
Yeah.
so I'll divide both sides by that, right? So what we finally get then is x dot equals x y dot plus 12y dot, and I can factor y dot out if I want to, over 20 minus y. Now we have to just fill in the stuff. Well, we know y. Do we know x directly? No, we don't, but can't we figure it out?
Yes.
Well,
Yeah.
see here,
Yeah.
Good, right? We can figure it out. It's after 1 second, so we could actually plug in 1 and find out if we know that y is 15, right? Let's fill in the blanks with the snapshot values now
well,
that
how do we
we've
figure out y is
differentiated.
15?
Because we wanted to find out how fast the shadow's moving at t equals 1. So if I plug 1 back up there, right?
Oh, now this whole thing makes sense.
Oh,
Now we get
that was
15.1.
my piece. It's just there now.
Okay.
Should have added that.
So if I want to find x, I can find it from right here then, can't I?
Yes, you can.
Right? I know that y is 15.1, and so I can solve, if I cross multiply, I get
Why don't you just do that for the one?
15.1x plus 15.1 times 12, whatever that is,
You don't know what it is?
equals 20x, right? So if I subtract 15.1x, I get 4.9x equals that, right?
What's that?
I don't want to think about that.
What's 12 times 15?
And so if I divide both sides by 4.9, I got x, right? So the exact value of x is 15 times, 15.1 times 12
That X out in 1 second.
over 4.9. Yeah, so that's x after 1 second, right?
Isn't that what we're trying to find?
Well, yeah, that's part of it, right?
And then you gotta-
So there's x after 1 second. Okay, we can plug that in. We got that taken care of. There's a number we can plug in, right? So that goes in for this guy. Okay, we know y. That's 15.1. The one thing that we don't know is y dot yet. But we can find y dot. If I know y, I can just differentiate both sides with respect to t. I'm given an equation of y in terms of t, right?
Stop talking, Lane. Damn.
If I differentiate these, what do I get? Y dot equals what?
Oh, frickin'
Well, look, you can tell me. 0 minus, yeah, what's the derivative of negative 4.9 t squared with respect to t?
9.8.
T. Yeah, there it is. Okay, so after 1 second, what is
Boy, I wish I knew what
that?
gravity was.
9.8 is weird.
So what is y dot at t equals 1?
Plug it in.
Negative 9.8.
Negative 9.8. Yeah.
Plug it in.
So,
Thanks, Shane.
so now we can plug all that stuff in, and we got an answer, right? So let's see, what's that going to look like? Then we're going to get x was that stuff right there, right? So we get 15.1 times, what are those numbers again? 12 and 4.9. Okay, times y dot, which was negative 9.8, plus 12 times y dot, which is 12 times negative 9.8, all divided by 20 minus 15.1. Plug that in, and we got an answer.
Okay. This, you know, this is really starting to get easy. I mean, calculus.
Okay, that's a pretty hard problem.
Yeah, is this supposed to be hard?
Yeah, this is some kind of joke.
Discuss it.
Chapter
34, 36.
Yeah, I didn't.
Guys, I'm in civics and we haven't had to read anything all year.
Wait, how many calculus are there?
What's that?
How many calculus are there?
How many calculus classes are there? Like in college? Well, I mean, usually 3 or 4.
Is this one?
Yeah, should be part 1.
Wait, are we going to get credits for the whole year or half the year?
We're only getting credit for half the year. Yeah.
But isn't it only like a one-term class in college?
Semester, right?
Or what do you learn?
Right. This would be the equivalent of a college semester. Okay, so if we plug all that in, then let's just do that. If we go second, no, not second. If I go alpha, make it a fraction. On top, we've got this 15.1 times 12 divided by.
Again.
Is that supposed to be plus or times? Plus. No, times. Times negative 9.8 plus this stuff. 12. Divided by.
Down.
Dog.
Divided by
20 minus 15.1.
Boom.
And the two.
Wait, how'd you get that? How'd you get the over thing? Fraction.
That's just
Alpha F1.
That's 4.9.
Or math.
So that's it. Negative 97.96 meters per second. That's pretty fast. But is that unreasonable? No, not really. I mean, if you look at this picture up here, this thing is going to be, the shadow is going to be moving across the ground really quickly. In fact, when it starts at, okay, now I really do want you guys to be quiet and watch this because this is pretty cool.
What was the answer?
Hey,
I'm
listen.
listening.
When this thing starts up here at 20, the shadow is being cast out at infinity, assuming the ground were going forever level, right? The line, the ray that describes where the shadow is going to sit is parallel to the ground, so we would talk about that in math or physics as being at infinity. And so initially, when this thing drops a tiny bit, I mean, think how fast that shadow's moving. It's going from infinity, or, after a millionth of a second, it's going to be out there some huge distance, billions of miles, and then a slight second later, it's a lot closer. That shadow is whipping across the ground pretty fast initially. As the angle gets more steep, it's not going to be moving as fast. But still, after 1 second, when this thing's only dropped 4.9 meters, the shadow's out there quite a ways, right? If this ball is moving at a rate of almost 10 meters per second down, decreasing, then that shadow's having to cover a lot more ground than the ball is, right? Because it's out there quite a ways further. And so even though that's a big number, and you might think, wow, that seems unreasonable, it's not. It's not. It's going to be going pretty fast. Now, why is it negative?
Because it's going that way from farther.
Well, because the shadow, the length of the shadow is decreasing. It's getting smaller. Yeah.
Can we see the answer one more time? I'm sorry, I got that. No, I got that.
Oh, the answer on the
Actual
calculator.
answer.
Yes, the answer.
Oh, you meant the answer.
Right there. Yeah.
Got it?
Wait,
Got
it's
it?
recording?
Is it?
Yeah, it's recorded. Good. This is a great one to record, isn't it? Okay, so we got it. Let's.
Mr. Oyster,